Now that we've set up a VTP server, a client, a transparent switch, VTP transparent switch, and another VTP client, I want to talk about configuration revision numbers. And the Cisco CCNA goes into detail about how configuration revision numbers work in with VTP. So for instance, if I open up the server, I'll take this server, and this is the server switch 0, and I'll just do enable, and I'm going to do a conf t and do a host name switch 0 so that it's obvious which switch we're in. But then let's do Control C and do a show VTP status. You'll see that the configuration revision number is 2, right? So in a lot of VTP networks, you can have more than one server, right? So we could have more than one VTP server, and the server, or the and in this case also the client with the highest revision number will basically be the one that disseminates to everybody else. And so that becomes an issue, and that is, how do you make sure that you don't wipe out the VLAN configurations by putting in a switch with a higher configuration revision number that would then wipe out the other switches, right? So the number of configuration revision is important. So let's go to this client and see if he has a matching configuration revision number. And once again, we'll just say conf t, whoops, Control Shift 6 to get out of that, conf t, and we'll say host name. This is switch 3, switch 3. Okay, so now you can see it right here, the host name. And we will look, show VTP status, and you see it's got a configuration revision number of 2, right? So they all have the same configuration revision number, right? So if I was to put another server on the network, or another client on the network with a configuration revision number of 0, kind of like when we put this client on the network, its configuration revision number was at 0, and then it adopted the VLANs from the other servers and clients on the domain that had a higher configuration revision number. So let's run a test, shall we? So what we're going to do is, I'm going to take out another switch. Okay. And this is going to explain a lot. I'm going to take out this switch. I'm going to move this down. No, I don't have to move it down. I'll take out the switch over here, and I'm going to call this the backup VTP server. Okay, it's the backup VTP server. And what we'll do is we'll go in here, command line interface, enable conf t interface FA0/1, and we'll set up the switch port mode to trunk, so we have a trunk port, and then switch port trunk allowed VLANs 1 through 99. Okay. Whoops. Not VLAN, not VLANs. Okay. Then Control C, and we'll say switch, conf t VTP domain 1. Okay. And we already know by default that VTP is enabled and that it's in server mode, so we don't have to tell it VTP mode server, right? So now, and let's do this, show VLANs. Whoops. Control C, show VLANs from privileged mode. You see that show VLAN, that it only has the default VLANs, VLAN 1, 1002, 1003, 4, and 5, right? So it doesn't have any VLANs. And we'll do a show VTP status command, and you see that the revision number is 0, right? So it has a lower revision number. It's got the correct domain name, and it's a server, right? But it doesn't know about all the VLANs because it's not connected to the network and it has a lower revision number. So if I was to connect this backup server to, let's say, this VTP client, then it would learn about all of the VLANs, right, from the VTP domain. But what if this VTP server was to go down and then we were to hook this one up? Now the server is supposed to be the one that adds and deletes and creates VLANs on the VTP domain, right? So the question is, if I put this backup VTP server, let's pretend this server goes down. So we're going to wipe out this link. Boom, trunk's gone. And we'll say this VTP server just went down, right? Gone. Okay, server went down. And we bring in our backup server, right? Now, the question is, when I hook up this server to this client, will this server, right, with no VLANs, wipe out all the VLANs off the client? Or will the client, right, and the transparent and the other client, will these clients in the transparent mode, will they actually teach the server about the VLANs because the client has a higher revision number, right? So remember that this server, right, and this server has a revision number of 0, right? And this switch, right, this is the switch server, VTP server, and this client right here, which is switch 1, right? Enable conf t hostname switch 1, right? This one has a revision number of 2. So can a client tell the server about these 11 VLANs because it has the higher revision number? So let's test it out and see who learns from who. Does the server wipe out the client, or will the client wipe out the server? So we'll take the crossover cable and we'll cable it up. Oops, and I put the cable on the wrong port. Sorry. Crossover cable, fast Ethernet 1 to fast Ethernet 1. Okay. And so the question is, who will propagate the VLANs? And the answer is the highest configuration revision number wins, right? So highest configuration revision number, right? The highest configuration revision number. Let's test it out. We go into the VTP server, and you'll see now on the VTP server, if we do a show VLAN or show VLAN, you see that it learned from the client about all of the VLANs, right? And now, if we do a show VTP status, its configuration revision is a 2. So the client actually taught the server about the VLANs because the client had the higher revision number, right? So the client had the high revision number, so then it informed the backup server and taught the backup server about the VLANs. So that's pretty interesting. So you could actually wipe out the VLAN information on the network if you put a switch onto the network that had a higher revision number than the other clients and servers. So a client can propagate VLANs to a server.